In this video, we'll deploy a Java Spring Boot microservice to an Amazon EKS cluster with a Jenkins pipeline. Hey, it's Stefan from DeepOcean, where we help you getting rid of your software monolith or your legacy software application. And if you're new here, make sure to subscribe, and all the links I mentioned in the video you'll find below in the description. And if you like this video, make sure to give me a thumbs up, that does make a difference. This is the fourth video of my Jenkins series. So if you're generally interested in Jenkins, make sure to watch the other parts. I've got Java Spring Boot microservices that uses a Postgres database. In this video, we'll use Terraform to deploy a Postgres RDS database to Amazon. Then we'll set up a pipeline on Jenkins that builds the microservice and deploys it to Amazon EKS Kubernetes cluster. At the end of the video, I'm having a bonus for you. We'll create a pipeline that destroys the RDS Postgres database. So make sure to stick to the end of the video. Let me show you the Java Spring Boot microservice for the User Micrsoservice first. A user basically has a first name, a last name and an email address. The microservice provides CRUD operations for the users. The users are stored in a Postgres database. Here we're having our user application. The next one is the user controller that has the post mappings, the put mapping and the delete mapping for the REST API endpoints. Then we have the user repository, which just is the interface for the JPA repository. Then we have the service, which is the interface for the user service, and the implementation of the service, which basically talks about the create user method, the update user method, and the delete user method. As you've seen, the microservice stores users in a Postgres database. Let us now see how we can create a Postgres database on Amazon's RDS using Terraform. So in the Terraform folder, we're having the environments folder and the modules folder. Let me show you the modules folder first. This is a module for the Postgres database, where the main stuff is basically here in the AWS DB instance in the db.terraform file. So here we are setting all the stuff mainly coming from the variables. Then we're having a DNS entry. So we're just creating a DNS entry for the database so that it can be more easily accessed. And we need an IAM policy document for that, so that AWS knows what you should be allowed to do. Basically that you're allowed to create the database. And the CloudWatch, which talks about AWS metric alarms. So these are just the modules, and we are calling the modules from the environments dev. So here we're having a backend configured. So we are saying the backend, basically the state of the Terraform, shall be on an S3 bucket with this bucket name. I'm always putting the account number to the bucket name, since the bucket names are unique across all buckets worldwide, and as I'm the only one having this account ID, I'm hoping to get a unique folder name by that. So this is the Terraform state, which is named tfstate userdev.tfstate in the bucket for the region EU Central 1. And we're having a DynamoDB table that basically stores the log whenever somebody's executing it, that no one else from the team can do it at the same time. Then we're having the provider, which just says we are using the AWS provider. So here we're having the module that calls the Postgres module that we just seen. It just puts in all the stuff that we need, which is the database identifier with a dash in it, and the database name, which mustn't have dashes, but we can use the underscore here. Interestingly, we're using the password in the username coming from the variables, but they will be coming finally from the Jenkins credentials, and they will be just forwarded expose the Jenkins file to the module. So the DNS zone that we're using is youtube.local, and the DNS record will be user-db. This is the VPC that we're using, and these two subnet names. So basically the database will be having two network endpoints, one in each availability zone, so that it's high available afterwards. We just need 32 GB of RAM, and we're using a dbt3.micro instance for that. The SQL version will be 13.3, and it will be just this parameter group. So then we're having the output TF, which just outputs the name DB DNS name. So the point is, when we're executing the Terraform, we might do it at another time than creating then deploying the microservice using Helm. Since we normally just create the database once, it takes probably a quarter of an hour, so we don't want to spend for every deployment something like 50 minutes. That means when we're deploying the Helm chart, we want to use this DNS name coming from the Terraform, and this is why we created the output here. So these are all the variables that we have to provide. So basically they're coming from the Terraform TFR files, where we only have one, which is the region. So basically the other two, database username and database password, have to be provided when executing the Terraform apply. Let us now create a Helm chart that deploys the microservices for the users to the Amazon EKS that uses the Postgres database. In the Helm folder, we'll find the Helm chart for the user microservice. So we're having the chart that just explains the chart itself. So the name is user, the description is user service. And then we're having the templates, where we're having a helper TPL. That is normally, in my case, only for having the template, the chart name available in the scripts. Then I'm going to deploy a deployment that contains the app full name. This is what I just said, coming from the helpers file. So basically the deployment has a name, the app label, and the specification. So the replicas is set here, so that we can have 1, 2, or 3 replicas, depending maybe on the environment where we want to run it. Then we're specifying the template, where we're having the container, which is mainly the image that we have to provide, and the environment variables. So here we're having the Spring data source. And here we see we have the DB DNS name that should be the output of the Terraform. That is not run in the same execution, but elsewhere. Then we're having the data source username that is stored in the Jenkins credentials, and the password that is also coming from the Jenkins credentials. And we also have a service to make it available to the outside world. We're having the service that is named then user service, and that selects all pods that have the app user metadata stored. So we can reach it over the port 80, and it will be forwarded to the target port 8080. And then finally we have the dev values, since we're only deploying to one environment here. So here we're having the image that we're gonna use for the user service. We want to have one replica, and we're having here the database URL with the username and the password. The next step is now to create the Jenkins files for the pipelines and create the jobs that covers the pipelines to get them executed. So let us have a look to the Jenkins folder in which I store all my Jenkins files. Here I'm having the Jenkins file for the Postgres create. So we're starting with 4 variables for the AWS account. I want to run the entire build process in a Docker image, and this is the Jenkins build image for that. And then we're having 2 credentials stored in the Jenkins credentials section, which is the AWS credentials. and the UserDB credentials. So then we're having the pipeline, we're having the environment variable AWS profile set, and basically it's just a single stage that creates the PostgresDB. Here I'm saying that I want to run it on a Docker and the Jenkins build image, and we're having just a single step in the Terraform environment's dev directory. Here I'm gathering my credentials from Jenkins and so the AWS credentials will be stored in the AWS access key ID, and the secret will be stored in the AWS secret access key environment variable. Same for the username password for the UserDB credentials, which is then DB user and DB password. So the cool stuff here is that Jenkins is clever enough to hide all the passwords in the doc file, since it knows that these variables contain passwords. So here I'm saying I want to start a script which contains the Terraform init that initializes Terraform by downloading all the modules into the local folder. And then I want to plan what it has to do. And here's the cool part. I'm setting the database username as well as the database password with the environment variables that we got from the Jenkins credentials. And I want to store the output in the file terraform.plan. Afterwards, I'm just applying the Terraform plan with the option auto approve, so that I don't have to enter yes or please continue. Let us now create the Jenkins job for that. So first I want to create a new tab here for the user, which is a list view. That's okay. And then I want to start creating the job. So we want to name the job create PostgresDB, and it's a pipeline. And I'm clicking OK. So here I'm selecting the pipeline. The definition is pipeline script from SCM. Then I'm selecting Git as my SCM. Here I'm pasting the URL of the GitLab repo that I'm using, and I'm selecting my credentials for that. My main branch is named main, and the Jenkins file is stored in the Jenkins folder and is named Jenkins file Postgres create, and I'm saving this. So this will run approx 15 minutes. We can just click on build now and continue with other stuff. Good. So let us now review the Jenkins file for the build deployment job. So this has again a couple of variables. So the idea is to build the image using Maven and then storing it to the ECR, so to Amazon's Docker registry, so that we have the image there that we can use afterwards to use the Helm chart, to deploy the Helm chart of the microservice on that. So I'm having here my Docker repo name, which is basically my ECR with the Docker repo name and the tag. So this is the complete Docker image, including the tag. Then we have the EKS cluster name and again the default region. So this time we're having two steps. The first one is the build step. Here we're having again the credentials, but this time we only need the AWS credentials. So here we are saying create the ECR repository. If it's already there, we will get an error message. This is why I'm just adding the pipe true here, so that the command will always succeed, also if the repo is already created. And then we want to log into the ECR. So for that we need to get the ECR password. And then we're just executing maven compile zip build. So we are compiling the Java project firstly, and then we are executing the zip build command to create the Docker image and push it to the ECR. To be able to push it to the ECR, we have to set the zip to auth username to AWS and the zip to auth password to the ECR password that we just gathered. And finally, I'm just providing the image name so that we can set this also here. So this is the entire build step. Afterwards we deploy it. We are doing this in the directory Helm user, and here we're having both credentials, so once the AWS credential and again the credential for the user database. So firstly, we would love to see the DNS name that we created in the Terraform execution earlier, which is currently running, so it's not the same execution time than the build and deploy process, since this will be done lots more often. So normally always somebody is pushing to the repo, but the database is normally only created once. So this is why I'm just executing here Terraform init, but on the Terraform folder obviously. And I'm executing Terraform in this folder, and I'm asking for the output of the DB-DNS name that we saw earlier in the output TF file. And we just want to split it in a way that we just get the value back, not the name DB-DNS name. And we are storing that in the variable DB-DNS name. Then we can update our kubeconfig, which is kind of logging into EKS. And then we are deploying the microservice using the Helm chart. So I'm always using upgrade -- install, which basically means we can later on use it to upgrade the Helm chart. So we don't have to delete it, we can just apply another version, which won't work for the Helm install. The Helm upgrade -- install means now that if it's not yet created, it will install it. So we're installing the user chart from the current directory. And here I'm setting some variables again, which is the Spring data source username, so that the Java Spring Boot app knows which user to use to access the database, and the password. So these guys here are coming again from the Jenkins credentials file. And I'm setting the DB-DNS name that we just gathered from the Terraform output. And finally, I'm adding the value files for the other values. Let us now create the Jenkins file for that, the pipeline for that, excuse me. So, that was wrong. I wanted to create a new item. This item should be named deploy user at the pipeline, and I'm clicking on OK. Here again I'm selecting pipeline script from SCN. I'm saying that I have a Git repo. Then I'm just pasting in my GitLab URL, since my repo is stored on GitLab. I'm using credentials to access this repo. I'm specifying my main branch as name, and I'm also specifying the correct Jenkins file for that. And I can save this. And just give it a try by clicking Build Now. So the console says an error occurred. Repository already exists, exception when calling create repository operation. The repo with the name user already exists in the registry, which is obviously saying, well, please give me a new repo, but it's already there. So just continue with the true. Then I'm getting the login password from the ECR. And finally, I'm starting the JIP. So we're having the build success for the first step, which was the build and deploy to ECR. And then we're having here this second step, should be here with the deploy step. In our directory with the credentials. So as you can see here, the variables containing the passwords will be masked. Here I'm using my Terraform command to get to initialize. Afterwards I'm getting my Terraform output on the dbDNS name. So that we're having here the username that we earlier used for the creation of the database. Then I'm logging into EKS, and here we're having the Helm upgrade install, which was successful finally. In the beginning, I've promised you a bonus. We will now create a Jenkins job that destroys the RDS Postgres database, so that we stop spending money on AWS. Let us now have a look at the Jenkins Postgres destroy file. So as deleting a database might be a bit tricky due to loss of data, I added a confirm stage. So where I'm asking myself, do we really want to destroy? And in case we have to type destroy and click on the proceed button. And only when we did it correctly, we will continue. Otherwise we'll throw an error and just abort. So here we're having the stage for the destroy Postgres DB, which is quite similar to the earlier creation of the database, but this time in the plan I added the -destroy option, so that the plan includes already the destroy operation that we afterwards just apply as we did it for the creation again. So let me now create a job for that. I'm clicking on new item. I'm naming this destroy Postgres DB. It's the pipeline and I'm clicking OK. Again, I'm selecting pipeline from SCM, I'm selecting Git. I am pasting my repo URL from GitLab. I'm selecting my credentials for accessing the GitLab. Then I need to change the branch specifier to main and just put in the correct script for the Jenkins file, which is Jenkins Postgres destroy. Save. And then we can start it to get the database destroyed. If you have any question, leave me a comment below. And if you like this video, please give me a thumbs up, that does make a difference. And also subscribe to the channel so that you get informed for more of the new videos. And watch the next video that is shown here on the screen.